Okay, in this video we are going to be looking at question 7 part 1 of the June 2014 Edexcel FP1 paper. And basically it's a question about 2x2 matrix transformations. Okay, so it says, in each of the following cases find a 2x2 matrix that represents part A, a reflection in the line y equals minus x, part B, a rotation of 135 degrees anti-clockwise about the origin, and part C, a reflection in the line y equals minus x, followed by a rotation of 135 degrees anti-clockwise about the origin. So part C is basically just putting these two things together. Right, okay, so 4 marks for this part of the question. So let's just jump straight into it. So part A, a reflection in the line y equals minus x. Now, whenever we deal with matrix transformations, I mean, you can just choose. There are, this is actually not a difficult one to remember. If you're interested in just remembering things, you can just remember it. But I wouldn't recommend that you do this with matrix transformations, okay? I would always recommend that you go through the thinking, the understanding of where they come from, because then when you're sitting in the exam, you can make sure you get it right, which is ultimately what you want. So, first of all, draw yourself a graph, and you draw a graph that represents the identity matrix. Now, remember, the identity matrix is this thing here. It's 1, 0, 0, 1. Okay, so it's the leading diagonal is 1, and all the other elements of 0. So this is the 2x2 identity matrix. And you want to represent that on a graph. So you can see here, and remember when we represent coordinates on a graph, we always work downwards. So this here is one coordinate, this 1 and the 0 in blue. That's one coordinate. And then the 0 and 1 is the second coordinate. Okay, so you can see here that I've already drawn on this 1 and 0 onto the graph. Okay, you move 1 unit across but 0 up. And I've always represented the 0 and 1 coordinate on the graph as well. You move 0 units across but 1 unit up. Okay, and I've colour-coded them there to helpful. And we're told in the question that we want to reflect it in the line y equals minus x. So you can see here that I've drawn the line y equals minus x in here in red. Okay, so where does this 1, 0 coordinate go? And then where does this 0, 1 coordinate go? And that will be our transformation matrix. So if we reflect this coordinate here, this 1, 0 in the line y equals minus x, it will end up down here. And that is the coordinate. What is that coordinate? You move 0 across, but you move negative 1 down. So 1, 0 goes to 0, negative 1. Okay? Let me just change colour for the green. Then let's look at the 0, 1 coordinates. You move 0 across, 1 unit up. You then reflect it in the line y equals minus x. It's going to end up over here, isn't it? Okay, and it's going to end up at negative 1, 0. Okay, so 1, 0 goes to 0, negative 1. 0, 1 goes to negative 1, 0. And that is your answer. Why? Well, remember, with matrix transformations, you multiply the transformation matrix by your coordinates. Okay, so let's just test this out. 0, negative 1, 0, negative 1, 0. I'm going to just move that negative over a little bit. And I'm going to multiply it by our identity matrix, which is our coordinate matrix, 0, 1. Okay, and you can verify that that is 0, negative 1, negative 1, 0. Because remember, whenever you multiply by the identity matrix, you just get the same thing back. It's the equivalent of multiplying by 1. Okay, so that is your 1 mark for part A. Now let's look at part B. A rotation of 135 degrees anti-clockwise about the origin. Now, this is why I say, for part A, you could probably have just remembered that. If you just want to just remember loads and loads of matrices, I'm not into that personally. It's not the way which I like to work. But if you wanted to, you could have done. But for part B, no, you can't remember that. You're having to actually draw it and go through the process yourself, because otherwise you just wouldn't know where to start. So let's first of all look at the first coordinate. We're still using the same coordinates, the identity matrix, but let's just look at them sort of separately. So let's first of all look at the first coordinate, the 1 and 0. Okay, so you can see I've drawn the 1 and 0, 1. And we then want to go through a turn of 135 degrees. So we want to turn through 135 degrees anti-clockwise. Okay, we're going to end up over here, aren't we? Something like that anyway. Sorry, my drawing isn't great. There we go. Something like that. Okay. Well, let's draw a little triangle, okay? Because what we want to do is we want to work out, well, what is that height? What is that bit there? And what is that bit there? okay? Because that will be our new coordinates, okay? So what is our x and y coordinate at our new point? We've moved through 135 degrees. Well, we can draw a little triangle. You know, you can see here we've got a triangle here. This distance is the same as this distance down here. We've got a little right angle triangle. And we know that angle in there because it's 180 minus 135 because the whole turn through that whole straight line is 180 degrees. So that little bit in there is 45 degrees. And I've blown that up a little bit bigger down here. Okay, and if we can work out this distance and we can work out this distance, then that's our new coordinates. So you should know from trigonometry, you should have seen this triangle before. We've got a length of 1 because that is the length of this coordinate here. You know, it's moving 1 across. That is the length of this hypotenuse is 1. What's this one here and what's this one here? Well, it's 1 over root 2, isn't it? And they're both 1 over root 2 because remember it's 45 degrees, so this angle is 45 degrees as well. You can work it through by sine, but this is 1 over root 2. And you can verify that because by Pythagoras, 1 over root 2 all squared plus 1 over root 2 all squared should equal 1 squared. Okay, because it's this side squared plus this side squared should equal that side squared. And let's just verify this. So you've got a half plus a half equals 1, which it does. So this is our new triangle. So these are our new coordinates. Remember, we've got to get our negative. We've got to get our positive and negatives around the right way. Remember, we're moving to the left. Our x-coordinate is in the negative direction. Okay, so it'll be not just 1 over root 2, but negative 1 over root 2. Okay, so 1 goes to negative 1 over root 2. That's our x. And our y, we're moving 1 over root 2 up still. So basically what we're doing is 1, 0 goes to negative 1 over root 2, 1 over root 2. Okay, so that is our first coordinate. Now let's look at the other one. Okay, the 0, 1 part of the identity matrix. Okay. So again, we're moving through 135 degrees anti-clockwise. So we're still moving in this direction. We're going to end up down here. Okay, there's 135 degrees. And we're going to end up down here somewhere. Okay, again, we're going to form a little triangle. That's still 1. That hypotenuse is still 1. Can still form a little triangle. Okay. Same thing again. That's a right angle triangle. This angle in here is still 45 degrees. You can verify that because that angle along that whole straight line, those two angles must add up to 180 degrees. So it's 180 minus 135, which is 45 degrees. Drawing it up a little bit more neatly here. It's still going to be, it's exactly the same triangle as what we had before. It's just flipped around. So the side lengths are exactly the same. So this is still 1 over root 2, and this is still 1 over root 2. But now, the x-coordinate is still negative, right? So the x-coordinate is still negative 1 over root 2. Okay, because we're moving to the left, negative 1 over 2. But we're also moving down by 1 over root 2. So the y-coordinate would also be negative 1 over root 2. So there we are, 0, 1 goes to negative 1 over root 2, negative 1 over root 2. So our whole matrix altogether, remember our 1, 0 went to negative 1 over root 2, 1 over root 2. Okay, and our 0, 1 went to negative 1 over root 2, negative 1 over root 2. Okay, and that's another mark for that question. So we got 2 marks out of the 4 already. Okay, and remember, it's exactly the same process. You can verify that. We can multiply this transformation matrix by the identity matrix, and we should get this matrix out again. So this is the transformation matrix, which moves our coordinates 135 degrees anti-clockwise. Now, let's look at part C. Part C says a reflection in the line y equals minus x, A, what we did for part A, followed by a rotation of 135 degrees anti-clockwise about the origin. So that's part B. So basically what we're saying is you want to move this thing, this identity matrix, you want to do A, then B. Okay, so you could either do it sort of thinking about it and drawing it out the same way. There's 2 marks works to this question. I wouldn't do it that way. Okay, I've got my identity matrix, which is a line, which is a reflection in the line y equals minus x. Okay, so reflection in the line y equals minus x is the matrix 0, negative 1, negative 1, 0. We work that out in part A. Okay, then anti-clockwise 135 degrees about the origin is the transformation matrix, we've got it here, negative 1 over root 2, 1 over root 2, negative 1 over root 2, negative 1 over root 2. Okay, we've worked those out. We've worked those out already in part A and B. Okay? So basically what we can do, it says we want to move our coordinates 1, 0, 0, 1. We want to do the reflection of the line y equals minus x first. So we multiply by minus x. We multiply by this transformation matrix. Remember, when we multiply by transformation matrix, we put it before the coordinate matrix. Okay, so this is our coordinate matrix. We then multiply by our transformation matrix. So we multiply by 0, negative 1, negative 1, 0. Okay, and then we want to multiply all of that thing by our anti-clockwise matrix of 135 degrees about the origin matrix, which is this thing here. Okay, so we want to multiply all of this thing by our transformation matrix. 1 over root 2, negative 1 over root 2, negative 1 over root 2. Okay, so we just multiply those things out, okay, and we should get, okay, this is just matrix transformation. I'm not going to go through matrix transformation. I've already done that in another video. And we should get 1 over root 2, 1 over root 2, 1 over root 2, negative 1 over root 2. And there we go. There's the final one. Where are the marks? There's 2 marks available. If you've shown that you do, if you got A and B wrong, say, but then if you've shown that you know which order to multiply these matrices in. So, for example, if these 2 matrices are the other way around, if you put 0, negative 1, negative 1, 0 in front of all this thing, that would be wrong. Okay, because look at what the question says. You just find it. It says the reflection first, then the rotation. If it was the rotation first, then the reflection, okay, then you would multiply, you would do the other way round, okay? So this would come first. The 0, negative 1, negative 1, 0 would come first, okay? But it's not. It's the reflection first, then the rotation, okay? So it's almost like you work outwards in the order which you do. So the outermost one is the last operation that you do, the last transformation that you do, okay? So if you've shown that you should do it in this order, that you should multiply your you do it in this order, that's worth 1 mark. So show that you know the order, that's worth 1 mark. To get the final answer, you get the correct matrix at the end.